In this lesson, we will discuss the process of optimization and develop a method to solve optimization problems. Now, what is optimization? If I say that engine of the car is set for optimum performance, what does that mean? Does it mean best performance, maximum performance? Yes, it could. There are many problems in real life, in engineering, medicine, industry, and all around us, where we need to maximize or minimize the performance. Now, for example, how many units of a product need to be produced to maximize the cost, maximize the profit, and minimize the cost? That is the process of optimization. You got to get a maximum profit level, at the same time keep the cost a minimum. So solving problems there whereby we find the maximum and minimum values of the function and conditions under which the maximum and minimum occurs is actually called optimization problems. All right, now what are the conditions for a function to have a maximum value or a minimum value? We have discussed that before. If you look at this, you got a relative minimum, a relative maximum. Now, what is the condition for a relative minimum? At a minimum, we have the first derivative equal to 0, and the second derivative is positive. Is that right? That's right. So this is the condition for a relative minimum. And what is the condition for a maximum? At a maximum, the first derivative is 0 and the second derivative is negative. So once we know the conditions for optimization, it's rather easy to do the problems. So let's start by doing a couple of optimization problems. Let's start with this problem. The sum of the perimeters of an equilateral triangle and a square is 10 meters. Find the dimensions of the triangle and the square that produces a minimum total area. Now here we need to minimize the total area. Now that means we need to set up a function for area. Now what are the variables there? The area must be set up as a function of a variable. What is the variable? Well, let's start by looking at what the variable should be. We've got a triangle, an equilateral triangle, so we can start by saying that let the side of the triangle be x. Is that right? And we have a square, and the side of the square can be another variable. But we need to deal with one variable. We will see that as we go on. So since we want to minimize the total area, we need to write an equation for the area A. We need to write an equation for area A using the dimensions of the triangle and the square. So we start by saying that let the side of the triangle be x and let the side of the square be y. All right, now tell me, is it possible to use this information to write a relation connecting x and y? What does this tell you? It says the sum of the perimeters of the equilateral triangle and the square. Remember, an equilateral triangle means all sides are of equal length. And the square also, all sides are of equal length. So, what is the relation between the variables x and y? The perimeter of the equilateral triangle is 3x, x plus x. And the perimeter of the square is 4y. So what is our relation? Our relation, therefore, is 3x plus 4y equal to 10. Is that right? Yes. So we have a relation connecting the side of the triangle to the side of the square. Well, we will leave that there, and we will need to use it as we move on. But the relation that we need to now set up is for the total area, because we need to minimize the total area. All right. In order to write an equation for the area of the triangle, we need the length of the altitude. Is that right? Yes. What is the equation for the area of a triangle? Area of a triangle will be 1/2 base multiplied by the altitude. Well, now what is the altitude or height of the triangle here? Because this is an equilateral triangle, you should know that the angle of each angle is 60 degrees, and the height of the triangle will divide the base into 2 equal parts. Is that right? That's right. So if this is h, we can say the area of the triangle is 1/2 of x. Is that right? 1/2 of the base times h, the altitude or the height. Now, is it possible for us to write h in terms of x using this angle? This angle is 60 degrees. We need to do that because we need to reduce the number of variables. So we need to replace this h in terms of x. What is that equal to? If this is 60 degrees, then sine of 60 degrees is opposite side divided by hypotenuse. The hypotenuse is x. So sine 60 degrees is h over x. That's right. Therefore, h equal to x times sine 60 degrees. And what is the value of sine 60 degrees? Sine 60 degrees is square root 3 over 2. And so, we have h equal to square root 3 over 2x. We can now bring this value of h in here, and that will give you the equation for area of the triangle. So area of the triangle is 1/2 x times h, and h is now replaced by square root 3 over 2x. And simplify that, that will be square root 3 divided by 4 times x squared. And this is the expression for the area of the triangle. Square root 3 over 4 x squared. Alright, we got the area of the triangle. How about the area of the square? Area of the square is y times y, y squared. Alright, now we need an equation for the area in terms of one variable. The area of the triangle is square root 3 over 4 x squared. Area of the square is y squared. Is it possible to write y in terms of x from the given information? What is the given information? The given information is 3x plus 4y equal to, we are given the perimeter. Is that 10 or 12? I think it is 12. Alright, so the total area is area of the triangle plus the area of the rectangle. But we need to write the area as a function of only one variable. We cannot have the two variables. That means we need to write this y in terms of x. And this is the given information. The sum of the perimeters of the triangle and the square is 10 meters. So 3x plus 4y equal to 10. We can now solve for y from here in terms of x and replace it there. Alright, let's do that. Therefore, y equal to 10 minus 3x divided by 4. Y squared, therefore, will be the square of that quantity. And so, a is now obtained as a function of x. Now, this is the method that we got to use in all optimization problems. You need to set up a function. How do you know what function that you are going to set up? If you are told to find the condition for maximum area, you've got to set up a function for the area. If you want to set up the condition for maximum profit, you need to write a function for the profit, an equation for the profit. That's right. So here we need to optimize the area. And what is the condition for optimizing the area? We got to write the equation for the area in terms of one variable. And this is the area of the triangle. This is the area of the square. And now, what do? We have the equation. We have now the function. We have the area function as a function of x, which is the side of the triangle. Alright, let's simplify this. This will be square root 3 over 4x squared. When you simplify this, you square the numerator, that will be 10 minus 3x squared, and square the denominator, that will be 16. Alright, now, at points where you have a maximum or a minimum, the derivative of the function will be 0. Or a maximum or a minimum occur at a critical number. So our next aim is to find the critical numbers of this function. A of x equal to square root 3 over 4x squared plus 10 minus 3x all squared over 16. What do? We find the derivative of this, set it equal to 0, and solve for x. Can you stop the video now and find the derivative of this quantity? Alright? Alright, let's talk about the derivative of this before we actually do it. Well, find the derivative of each term. Alright, derivative of this term, square root 3 over 4 is a constant. So that will be that constant number times the derivative of x squared. We are finding the derivative of area with respect to x. And therefore the derivative of x squared with respect to x is 2x. So that will be square root 3 over 4 times 2x plus. Remember, very often you might want to look at this as a quotient. Now, this is not a quotient because the denominator is a constant. So you can write it as 1 over 16 times the derivative of the numerator. Now, what is the derivative of 10 minus 3x all squared? That will be 2 times 10 minus 3x to the power of 1 times the derivative of 10 minus 3x. What is the derivative of 10 minus 3x? It is negative 3. So it will be again 2 times 10 minus 3x multiplied by negative 3. That is the derivative of the numerator. And that multiplied by 1 over 16 is the derivative of this whole quantity. Alright, let's write it down. So, we have our function is a as a function of x. Look at the way I wrote it. square root 3 over 4x squared, 1 over 16 times 10 minus 3x all squared. So that the false impression of that being a quotient is removed. And now, the derivative of that will be square root 3 over 4 times the derivative of x squared is 2x, plus 1 over 16 times the derivative of 10 minus 3x is 2 times 10 minus 3x, times the derivative of 10 minus 3x is negative 3. Now simplify that. What does that give you? It will be square root 3 over 2 square root 3x. Remember, this 4 can be cancelled with this 2. That gives you square root 3x on the numerator divided by 2. Square root 3x. Now remember, don't confuse this as square root of 3x. No, this is square root 3 times x divided by 2 minus 16 and 2 giving an 8 on the denominator, and there is a 3 here. The negative sign will make that a minus, so you got minus 3 over 8 times 10 minus 3x. Well, set that equal to 0. That becomes a very simple process now. Can you solve this equation for x? Well, what you need to do is distribute that. So that will be square root 3x over 2. Don't read it as square root 3x. It is square root 3 times x. So square root 3x over 2 minus 30 over 8. Multiply that. And then two negatives become positive. Minus 9 over 8x equal to 0. And of course we combine the terms in x on the left side. Is that right? That would be square root 3 over 2 plus 9 over 8x. That's right. Square root 3 over 2 plus 9 over 8x minus 15 over 4. 30 over 8 is 15 over 4. Which is the same as, take the 15 over 4 to the right side. And what all you need to now do is to find x, divide the right hand side by this quantity. So x equal to, try and do that on your own. I got that simplified as 30 divided by 4 square root 3 plus 9. Is it okay, or do you want me to help you? Now, how do you know that at this x value the sum of the areas will be a maximum, or the function that we constructed for the area will be a maximum? Right? It's a very simple test. Find the second derivative and see if that is positive or negative at this x value. That's the test. So let's find the second derivative of our function. This is the first derivative. So the second derivative will be the derivative of that. Find the derivative of each term. The derivative of square root 3 over 2x. See, this number is square root 3 over 2 times x. The derivative of that will be square root 3 over 2. And the derivative of, let's leave the negative 3 over 8 there. It will be negative 3 over 8 times derivative of 10 minus 3x. What is derivative of 10 minus 3x? That is negative 3. So it will be negative 3 times negative 3 over 8. That is negative 9 over 8. So the second derivative is square root 3 over 2 plus 9 over 8. Now, look at this. Can this ever be negative? No. This quantity is always positive. What that means is, for all values of x, the given area, the sum of the area of the triangle and the square will be a minimum. So at this given x value, the sum of the areas will be a minimum. What that means is, since for all x values the second derivative is positive, this x value corresponds to a minimum total area. And we now got the value of x that gives the minimum total area. How about y? We need also to find the value of y. Well, we have a relation between x and y, is that right? Well, we know that y equal to 10 minus 3x, is that right? Y equal to 10 minus 3x divided by 4 square root 3 plus 9 over 3. See, we replace our x by this quantity to find the value of y. I hope you remember that relation. We have it here. Y equal to 10 minus 3x divided by 4. And in that, x is replaced by 30 over 4 square root 3 plus 9. And simplify that. Can you simplify this without any trouble? Well, that will be, you can take this as the common denominator, 4 square root 3 plus 9. And when you do that, 10 will multiply with that. So on the numerator you have 10 times 4 square root 3 plus 9 minus 3 times 30 is 9. That's the numerator. And the denominator will be this, will then get multiplied by this 4. That will be 4 times 4 square root 3 plus 9. I hope you understand that simplification. It's a very simple phenomenon. That is the common denominator, and that will multiply with 10. That will be 10 times 4 square root 3 plus 9 minus 90. That is now on the numerator. Now, the common denominator is 4 square root 3 plus 9. And this denominator and that will now combine to produce this. Okay, and that will be, if you simplify this, you can see 10 times 9, 90, minus 90. Those will cancel. So the numerator is simply 40 square root 3, and the denominator is 4 times 4 square root 3 plus 9. And that will be, 4 goes with this 40. 10 square root 3 over 4 square root 3 plus 9. That is the value of y. That will produce a minimum area. And this is the value of x. Therefore, the dimensions of the equilateral triangle and the square, that will produce a total minimum area is x equal to this quantity and y equal to this quantity. Now this is a very typical optimization problem. Okay? Let's try another one. A rectangle is bounded by the x and y axis and the graph of y equal to 6 minus x divided by 2. What length and width should the rectangle have so that the area is a maximum? Well, here we are talking about the area of a rectangle. We need to maximize that area. So we need to aim at setting up an equation for the area in terms of the length and width of the rectangle, because we've been told what length and width should the rectangle have. We must set up an equation for the area of the rectangle in terms of its length and width. Now, can you picture this problem? Here we have y equal to 6 minus x divided by 2. So if I give you a graph outline here, can you draw the graph of this line? Y equal to 6 minus x over 2. Now if you divide each of this by 2, it will be 3 minus x over 2. Is that right? So the equation is y equal to 3 minus x over 2. That means 3 is the y-intercept. And the slope is -1/2. right? So if you write down that equation, do that now. Write down y equal to 3 minus x over 2 and tell me what is its x-intercept. What is the x-intercept of that equation? Well, have you got that? Our equation is 6 minus x over 2. The x-intercept occurs with y equal to 0. Y equal to 0 occurs here when the numerator is 0. Therefore, the x-intercept is at x equal to 6. That will be the x-intercept. And the y-intercept will be 6 over 2, that is 3. So this is the equation of the line. That is y equal to 6 minus x over 2. And the rectangle is bounded by this. Is that right? A rectangle is bounded by the x and y axis and this line. So the rectangle is in here. So we can draw it anywhere we want as long as it is bounded by x and y axis and that line. So let's draw that rectangle. We draw the rectangle with its length along the x-axis and width along the y-axis and touching the graph of this function. So this is our rectangle. Its length is x. Width is y. Is that right? This point will be called xy. That means its length is x and the width is y. The corner of the rectangle is xy, means that the length of the rectangle is x and its width is y, so that the area is x times y. Well, so area is x times y, and we need to find the values of x and y which will make this area a maximum. Well, as we did before, you cannot handle a function with two variables. It means we need to eliminate one in terms of the other, which we already know. So what we need to do is replace this y in the equation for the area with this value of y that is given. Y equal to 6 minus x over 2. So let's do that. Now, 6 minus x over 2 is 3 minus x over 2. Therefore, area as a function of x is x times y. X times, this is y, 3 minus x over 2. Now, distribute that. That will be 3x minus x squared over 2. X squared over 2 is simply 1/2 x squared. And find the derivative of that. Why do you need the derivative? We need to find the critical numbers, because a maximum or a minimum occurs at a critical number. So find the derivative. Now, the derivative of each term. What is the derivative of 3x? It is 3. And what is the derivative of minus 1/2 times x squared? The derivative of x squared is 2x. And that is minus 1/2 times 2x. And the 2 and 2 goes. So that gives you 3 minus x is the derivative. It's a very simple process. And the critical number occurs where the derivative is 0. So set this derivative equal to 0, and that gives you x equal to 3. Alright, if x equal to 3, what is the value of y? You can figure that out straight away. Put x equal to 3 and find the value of y. Now, how do you know at x equal to 3 we will get a maximum? Because at the critical number, the area can be a maximum or a minimum. We need to establish that it will be a maximum by using our test. What is the test? At a maximum, the second derivative must be negative. So if this is the first derivative, let's find the second derivative. A prime x equal to 3 minus x. A double prime x is derivative of 3 is 0, derivative of negative x is negative 1. And that negative 1 will be negative for all values of x. That means because the second derivative is negative for all values of x, the second derivative is negative all through the function, all through the domain. Therefore, x equal to 3 corresponds to a minimum, corresponds to a maximum value of the area. Now, so a double prime x is less than 0 for all values of x. Therefore, x equal to 3, the area of a of x is a maximum. How about then y? Y equal to 6 minus x over 2, and using x equal to 3 gives you y equal to 1.5 units. So in order that the area bounded by the x-axis, y-axis, and the graph of this function be a maximum, we got to have x has to be equal to 3 and y has to be 1.5. All right? And what is that maximum area? That maximum area will be a of 3. So go to your function and replace x by 3, and that gives you the maximum area is 4.5 square units. All right, now try this on your own. A farmer plans to fence a rectangular pasture adjacent to a river. If the area of the pasture is 180,000 square meters, what length and width of the fenced area will require the least amount of fencing? Well, look at that again. What length and width of fencing? That means you've got to have variables representing the length and width. Requires the least amount of fencing. What are we talking about here? Are we talking about area or perimeter? Least amount of fencing means the least length of fencing. So you got to optimize the perimeter of the fencing. You need to write an equation for the perimeter of the fencing after setting it up. You've got to draw a diagram and assume that the length is x and the width is y, and add up to produce the total perimeter and obtain a function. And it is given that the area of the pasture is 180,000 square meters. In other words, if you now set up what is area in terms of x and y, you will be able to eliminate y in terms of x, and then bring it into this equation. Obtain the equation of the perimeter only in terms of x, and then proceed. That's the method. All right, let's try another one. A solid is formed by adjoining two hemispheres to the ends of a right circular cylinder. The total volume of the solid is 12 cubic centimeter. Find the radius of the cylinder that produces the minimum surface area. Well, you need to picture the problem first. What is a right circular cylinder? A cylinder which has the cross section as a circle. That is a right circular cylinder. Now, in this case, we have a solid is formed by adjoining to two hemispheres. A hemisphere is half of a sphere. So what you have is one end of the right circular cylinder, you have a hemisphere. That's So a hemisphere on one end and a hemisphere on the other end. That is what your solid is like. Okay, the total volume of the solid is 12 cubic meters. So what you need to do is, we need to find the value of the radius. What radius, remember the radius of the cylinder and the radius of the sphere, the hemisphere, will be the same. Now, let the radius be r and write an equation for the volume of the whole solid and set it equal to 12. Now, in addition to the radius, there will be other variables coming in there which need to be replaced in terms of the radius. That's our whole idea. Now, find the radius of the cylinder that produces the minimum surface area. So, the function that you need to optimize is the function for the surface area of the whole cylinder. Alright, let's first of all draw a diagram of this. I think I have a diagram here. Now here, this is the cylinder. This is a hemisphere on one side, a hemisphere on the other side. Alright, I hope you picture the problem like this. Let the length of the cylinder be L and its radius be equal to r. The radius of the cylinder and the radius of the hemisphere are both the same. Alright, can you write an equation for the total volume of this? What is the volume of a, remember what I'm showing you is a hollow one, but in the problem we have a solid cylinder. So what is the volume of a right circular cylinder? The volume of a right circular cylinder is the base area. Base is a circle. Base area is pi r squared times L. That is the volume of the cylinder. What is the volume of a sphere? Volume of a sphere, we have been doing that for some time, is 4/3 pi r cubed. Now, there is half a sphere on the right side and half a sphere on the left side. So you have total one whole sphere. That means the total volume of the two hemispheres is 4/3 pi r squared. Therefore, the total volume of the cylinder plus the two hemispheres will be pi r squared L times 4/3 pi r squared. That's the total volume, and that total volume is given to be 12 cubic centimeter. Now, write that down and leave it aside, because that will help you to eliminate one unnecessary variable we have, which is the length of the cylinder. We need to write the length of the cylinder in terms of the radius. Well, the function we need to set up is the surface area as a function of the radius. We need to minimize the surface area. Alright, tell me, what is the surface area of a right circular cylinder? You see, a cylinder, if I open up the cylinder, what will it look like? It will be a flat, like a piece of paper, is that right? Now, if you watch this, this is a right circular cylinder, and if you open up, it is a flat sheet. Therefore, the area of the surface area of the cylinder is actually the surface area of that sheet, which will be length times width. Is that right? That's the width, that's the length. And the length of the cylinder, we already know it is L. Now, what is that width? That width becomes the circle when it becomes a cylinder. And the radius we know is R. And what is the circumference of that circle? It is 2 pi r. So, the surface area of the cylinder is this length 2 pi r times length. And what is the surface area of a sphere? The surface area of a sphere is 4 pi r squared. Since we have half a sphere on the right, half a sphere on the left, the total surface area is the area of one sphere, that is 4 pi r squared. All right, let's put it all in writing now. So first we write area A of the solid as a function of r, the radius of the cylinder. Now the radius of the cylinder is the same as the radius of the hemisphere, which we already said. If r is the radius of the cylinder and L its length, then the area A1 of the curved surface, that's what I just showed you. The area A1, I'm talking about the curved surface of the cylinder, will be equal to 2 pi r times L. Is that right? 2 pi r is the circumference of the circle, that is 2 pi r, and L is the length. That is the surface area A1 of the right circular cylinder. And the two hemispheres together form a sphere, and the total area will be 4 pi r squared. Therefore, the total surface area of the solid is 2 pi r L plus 4 pi r squared. Now, this is the function that we need to optimize. We need to maximize or minimize. All right. Now, we need to write this as a function of r, because we need to find for what value of the radius will this be a maximum. That means we need to eliminate this L and write it in terms of r. And that is where we are going to use the given volume value. All right, we need to express A as a function of r. And this can be done by replacing L in terms of r. Let's do that. The volume of the solid is given. We need to write an expression for the volume V of the solid in terms of L and r, and then solve for L in terms of r. All right, let's do that. Volume V1 of a sphere of radius r. What is the volume V of a sphere of radius r? 4/3 pi r cubed. And since we have a half a sphere on the right and a half a sphere on the left, we have one whole sphere, and this is the total volume of those two hemispheres, and I call it V1. And volume V2 of the cylinder, what is the volume V2 of the cylinder? We said is the base area, which is the area of the circle, times its length, is pi r squared times L. So the total volume is the volume of the sphere plus the volume of the cylinder, that is 4/3 pi r cubed plus pi r squared L. And this is given to us as, is that 12 meter cube or meter square? Yes. V is given to be 12 centimeter cubed, so volume. So set this quantity equal to 12 and solve for L in terms of R. There we have 12 equal to 4/3 pi r cubed plus pi r squared L. And what we need to do is take this term to the other side, 12 minus this quantity, and divide that by pi r squared to get L. Or make it simpler by multiplying each term by 3 to get rid of that 3. So 36 equal to 4 pi r cubed plus 3 pi r squared L. And now solve for L. We take the 4 pi r cubed to the other side, 36 minus 4 pi r cubed, and divide by 3 pi r squared. And divide that into two terms, 36 divided by 3 pi r squared minus 4 pi r cubed divided by 3 pi r squared. And that gives you, simplify that, 36 divided by 3 pi r squared will be 12 divided by pi r squared. Is that right? And minus 4 pi r cubed divided by 3 pi r squared is 4/3 r, because pi and pi cancels, r cubed goes with r squared, leaving an r. So we've got L in terms of r as 12 over pi r squared minus 4/3 r. Therefore, in our function for the surface area, we will replace L with this quantity. Now, what is the area function we have? The area function we produced earlier is A equal to 2 pi r L plus 4 pi r squared. And here, this L is going to be replaced by this quantity. Let's do that. So we've got A equal to 2 pi r times L is replaced by 12 over pi r squared minus 4/3 r plus 4 pi r squared. Now, we need to optimize this function. That means we need to find the critical number, the value of r that will make the first derivative equal to 0. And let's simplify this. Let's multiply this out. Multiply each term with 2 pi r. When you multiply 2 pi r by 12 over pi r squared, a pi and r cancels, leaving us the first term 24 divided by r, and the second term will be h pi r squared over 3, or h over 3 pi r squared. That is multiplying these out, plus 4 pi r squared. Can you combine these two? Negative 1/3 pi r squared plus 4 pi r squared. What does that give you? Can you do that mentally? Because these are both pi r squared, is 4 minus h over 3. What is 4 minus h over 3? Is 4 minus h over 3 is 4/3? Yes, I think so. So this will be simply 4/3 pi r squared. There you go. So we got area as a function of r is 24 over r minus 1/3 pi r squared plus 4 pi r squared. And combining this will give you pi r squared times 4 minus 1/3, which is 4/3. So you got 24 over r plus 4/3 pi r squared. Now set the derivative of this equal to 0 and solve for r. Can you find the derivative of this? Tell me, what is the derivative of 24 divided by r? Well, you should know that the derivative of 1 over x with respect to x is negative 1 over x squared. Here we find the derivative of 24 over r with respect to r. That will be negative 24 over r squared. The derivative of 4/3 pi r squared. 4/3 pi is a constant. The derivative of r squared is 2r. So, this is our area function. The derivative is negative 24 over r squared plus 4/3 pi times the derivative of r squared is 2r. Now, that will be negative 24 r squared plus 1/3 pi r, and set this equal to 0 and solve for r. Let's first of all simplify this. Take 3r squared as the common denominator. When 3r squared is taken as the common denominator, 3 will get multiplied with negative 24, giving you negative 72, plus r squared will multiply here, giving you 8 pi r squared, and the denominator will be 3r squared. It's now easy to set that equal to 0, because when this is 0, this will become 0 when the numerator becomes 0. So we set a prime r equal to 0 and solve for r. There you go. And when will this quantity become 0? When the numerator equal to 0. So take the numerator and set it equal to 0. Or we get 8 pi r cube equal to 72. Or r cube equal to 72 divided by 8 pi. That means r equal to cube root of 9 over pi. 8 goes 9 times in 72. And that's approximately, not the exact value, approximately 1.12. So, for r equal to 1.12, the surface area will be a maximum or a minimum. What is the condition for maximum or a minimum? For a maximum, the second derivative will be negative, and for minimum, the second derivative will be positive. Is that right? So for a conclusion, we use the second derivative test. Now, this is the first derivative. Can you find the second derivative of that? Now, a prime r we know is negative 24 over r squared plus 8 over 3 pi r. What is the derivative of negative 24 over r squared? Well, use the quotient rule there. R squared times the derivative of negative 24, that is 0. So 0 minus negative 24 times the derivative of r squared is 2r over the square of the denominator. All right, write it down and see whether you can come up with a derivative value for that. What is the derivative of 8/3 pi times r? That will be 8/3 pi. So, the derivative of negative 24 over r squared is 48 over r cubed. Did you get that? One more time. It will be r squared times the derivative of negative 24 is 0. So on the numerator you have 0 minus this negative. Minus negative become positive. 24 times the derivative of r squared is 2r. 24 times 2r is 48r. So that will be on the numerator 48r. Denominator will be the square of r squared, r to the power of 4. 48r divided by r to the power of 4 is 48 over r cubed. Plus the derivative of 8/3 pi r is 8/3 pi. Now, can this quantity ever be negative? No. That means the second derivative will be always positive. That's right. Now, if you put, earlier on we showed that when r equal to 1.12, the area can be a maximum or a minimum. And when r equal to 1.12, the second derivative is 38.3, which is a positive value. In fact, r can only have positive values. And because of that, this quantity will be always positive for all values of r. Alright, that means we have a prime 1.12 is 0, which means 1.12 is a critical number. And a double prime 1.12 is greater than 0, which means at r equal to 1.12, there is a minimum value for the A. Therefore, A of 1.12 is a minimum at that value. And what is that minimum area? A of 1.12. You go to the surface area equation and replace your r by 1.12. So A of 1.12 is 24 over r, 1.12, plus 4/3 pi times 1.12 squared. And that is 26.7 centimeters squared. And that is the minimum surface area of that solid. And that surface area occurs when the radius equal to 1.12. Now these are good problems you need to practice on your own to make sure that you understand these concepts. Now try this on your own. The rate of flow of a fluid in a certain pipe is given by R equal to V over 40 plus 0.4 V squared. The rate of flow as a function of the flow speed. Now, where V is the average speed of the fluid in the pipe, what fluid speed will maximize the rate of flow? What value of V will maximize the value of R? Well, you need to find here R is given as a function of V, so you don't need to worry about eliminating any variable. What all you need to do is find the derivative of this with respect to V, set it equal to 0 and solve for V, and then find the second derivative and show that at that V the second derivative is negative, because at a maximum the second derivative is negative. I hope you know how to find the derivative of quantities like this. Is that right? Now try that on your own. Denominator times the derivative of the numerator minus numerator times the derivative of the denominator all over the square of the denominator, and simplify it. It is simplifying algebraic quantities that most of you have trouble. So try this and let me know how you're doing. Okay? Before we close, let me give you another simple problem. Something like this. The sum of two numbers, the sum of two numbers is, say, 250. I'm just making it up. The sum of two numbers is 250. Now, what are those two numbers? What are those two numbers that satisfy this, that will make their product a maximum? See, a typical problem. Well, I hope you can read it. It doesn't matter if you can't read it, but you understand the problem. The sum of two numbers is 250. Now, there are many numbers that add up to 250. 200, 250, well, 125, 125. There are so many numbers that add up to 250. But there are just two numbers that will add to give you 250, and the product will be a maximum. We need to find two numbers such that they add up to give you 250, and the product is a maximum. So let's take away this illegible writing and transfer that into mathematical interpretation. We are given that the sum of two numbers is 250. So start by doing what? Let the numbers be x and y. So that we can now say x plus y equal to 250. Now that establishes a relation between x and y. What is it that we need to find? Find the values of x and y such that their product is a maximum. That means set up a function for the product of the two numbers. So let the product be called p. P is equal to x times y. Now we need to optimize this function. That means we need to eliminate one variable in terms of the other. So replace your y in terms of x. Now from our first equation, what is y equal to? Y equal to 250 minus x. There you go. And therefore, our function now becomes p equal to x times y, x times 250 minus x. Now that will be 250x minus x squared. Now we need to optimize it, so let's start by saying that this is our function. P of x equal to 250x minus x squared. Well, when the product is a maximum, its derivative will be 0. So p prime of x equal to, it's a very simple one, derivative of 250x is 250 and derivative of x squared is 2x. And set it equal to 0, and that will give you x equal to 125. It tells you that when x equal to 125, the product will be a maximum or a minimum. Well, how do you test it? See what the second derivative is at this x value. If the first derivative is this, p of p prime x is 250 minus 2x, tell me what the second derivative is. P double prime x is derivative of 250 is 0, derivative of minus 2x is negative 2. That means for all values of x, the second derivative is always negative. And that tells you that x equal to 125 will give you the product a maximum. In that case, what is the value of y? If x is 125, y will be also 125. So the maximum product occurs when x equal to 125 and y equal to 125. No other numbers that add up to 250 will give you a product as much as 125 times 125. That's what it means. All right, I think that we have enough of this lesson.